Julia, no. Twitch is what we're on right now. I just got 100 gifted subs. Submarine sandwiches. 100 gifted subs means someone just sent 100 Subway footlongs to Laurie's Deli. Created by Alyssa. Okay, loggies. Loggies. Okay. Agree or disagree?
Disagree.
2 to the third power equals 8.
Agree.
Yes. Hopefully agree with that.
Yeah.
There's a different way of saying that. All right. Sean, could you put that away, please? Thank you. Okay. Different way of writing this. I could write log base 2 of 8 equals 3. That's pretty much the main idea that you have to know to understand logs. It's just another way of writing a relationship between 3 quantities, where it's an exponential relationship. So I want to give you a quick little bit of background on this. Think back to a simpler time in your life when you were just a wee person and you learned about like 3 times 6 equals 18. Back then you probably used an X to represent multiplication, but you get the idea. And then the mean teacher went, but wait. Because I mean that means some stuff, right? That means, for example, that if you give 6 people 3 cookies apiece, there's been 18 cookies given. Or if there's 3 rows of 6 bananas, there are 18 total bananas, right? That kind of thing. But you could also say that 6 is equal to 18 divided by 3. Is that not, that's an equivalent way of writing that relationship, right? Mm-hmm. So that's all that's happening here. Is in this case, or way earlier on, you learned, well, there's this thing called multiplication, and there's like sort of an inverse way of writing that called division. Same thing, exponentiation, and then the logarithmic statement. So, what's wrong? No. What's the matter?
Logarithms are not cool.
No. Stop cutting your paper. No, they're not hard. Okay, so this is all there is to it. It's just a different way of writing this relationship. So then you might go, okay, I get there's a different way of writing it, but division, right? We kind of know, why do we bother talking about division? Why invent that operation? Well, it's really nice when you want to say something like, oh, I got, for example, you might say 5 times what number would make 17? Like, is it possible to make 5 times a number to equal 17? The answer to that question, yeah, there is. There's a number. That number is called 17 divided by 5. 17 fifths. Which you could then, I mean, this one's a pretty easy one to do, but that can be written as a decimal. That make sense? Okay. The same thing's true for logs, right? So with logs, I might say something like, is it possible for 5 to some power to equal 31? Is there a number out there where 5 raised to a power, 5 raised to that number would give you 31? Is it possible? Yeah, it's possible. Guess what number it is?
3.6.
Log base 5 of 31, of course.
Of course.
Well, do you see how this is the same as that? You see? This is a good time for questions if you're lost at all right now, if you're not sure what I'm talking about. You sure? Help me out here if you're confused. This is not a complicated idea, but maybe there's some sort of mental block that's like, it's not making sense, but we sure we're okay to move on? Yeah. Okay, good. Who wants to flex their incredible calculation skills and make a guess as to how big this number is? Log base 5 of 31. Like 2 point something. That's a great answer. How do you know it's 2 point something?
Because it was 3 out of 100, maybe like 125.
And if it was 2, you'd have, right, so
That's a big leap.
if you're looking at this, you might look back at this step and go, well, 5 to the 2 makes 25, 5 to the 3 makes 125. Well, 100 is just 100, I know it's 100 something. So by the way, you think it's more like 2.1 or more like 2.9? Probably more like 2.1-ish. And I can ask the calculator, oh, great calculator. What is log base 31? Sorry, log base 5 of 31. What does it come out to be? 2.133656215. And that's an irrational number. Okay, so this number here is not rational. It's going to be some crazy decimal that goes forever and never repeats. Oakley dokley? You're killing.
What is the value behind log?
The scale is
You can
taking
plug it
class
into a
now.
calculator, and it'll give you the number. But
There is
How
no
would you
number
solve
value of
it?
log.
Yeah, what does it mean?
Log mean
Well, firstly, just
5.
take it in an abstract sense. It's a way of writing a number that satisfies a certain condition. So if I said, is there a number? So again, like, is there a number where if you raise 5 to that power, you get 31? There's no nice way to write that number. The only way to write that number exactly is to do this. Same way that square roots work. Like, why do square roots exist, right? If I say x squared equals 36, well, there's a nice, we just know the answer to that, right? But what if we say, what number squared makes 17? Well, the only real way to write that number, exactly at least, is to say this. We call that the square root of 17, right? So logs are, to me, logs are fascinating to me as like just from an educational perspective, because a lot of people go, they're like, why does that even exist? Why make that when they they haven't really put that same line of reasoning to like literally everything else. Why have subtraction? Right?
Fun.
Why have division? Hopefully I answered that question for you. Why have division? Why have a square root? Make sense? Why have exponents in the first place? Well, it's a lot easier to write 2 to the 10th versus 2 times 2 times 2 times 3. If you want to know a nice application of this, I'll show you real quick. This is what we're going to cover later in our next little unit, but you might say something like, here's a very practical question. If you were getting say 7% interest on so let's say simple 7% interest, 7% annual interest, how many years would it take to go from say $10,000 to $50,000?
like 14 years.
How'd you do that?
No, wait, never mind.
I think it's more than 14,
It's
but
not doubling.
well, what you do is you'd say, well, you take your 10,000 and you multiply it by 1 plus 7%, and then you'd be multiplying that every single year for T years until you eventually hit 50,000. Use a little bit of algebra here, and you'd say, okay, divide both sides by 10,000, and now you get this question. These questions pop up all the time when you're studying growing things. Anything that grows. Most things that grow exponentially. Maybe instead of saying most, I'll say a lot. There's a lot of things that grow exponentially. So in this case, I might ask this question, well, what power do I have to raise t to get 5? Did I say that wrong? What power do I have to raise 1.07 to? What power t would give me 5? Is this making any sense?
Yeah.
So the answer to that is log base 1.07 of 5 would give me my t value. And I would say, some smart people have written algorithms, right, that will tell me the value of this number. Just like in the same way that if I said 293 times what makes 7,662, how would I solve that?
Divide.
Mr. Calculator I would do the division, right? I'd say, thanks, calculator. 7,662 divided by 293 is giving me 26.15, blah, 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 right? In this case, I'd say, Mr. Calculator, what's the log, checking into the calculator. Taking bets. How long does it take to multiply your investment by 5 at 7%? 23.8 years, roughly. If you were curious. Cool beans? Okay, so seven's pretty solid, yeah. If you really want to study, if you want to do the mathematics of like investment growth and stuff, it's very fascinating. But you have to then, it's more complicated because you have to say, well, what if I'm not only starting with that 10,000, but also contributing every month? What if I'm putting in another 400 every month?
Right.
And then that money gets added to the amount that's compounding. You end up with a much more complicated sort of relationship.
Much more big leaves.
What's average interest here? Like around 5-ish?
Average, what do you mean average?
Like just maybe for here. Because it doesn't change like statewide or is it just like?
That's what you're talking about. If you're talking about like a federally insured
Yeah.
savings account, you're
Yeah.
looking at what, like 1% or something. But when people are talking about getting like 7% growth, they're talking about having their money in like a diversified portfolio of investments. Like usually your investments are spread out over like the whole stonk market essentially. And so that stonk market tends to grow at something like 5, 6, 7, 8% depending. Yes.
I'm just on 2D. Does the x to the negative third over y to the negative third, does that just flip to y to the third over x to the third? Okay.
Okay, so the questions on your assignment, I hope I didn't scare you with that interest thing. That will hopefully be easy peasy once we realize that logs aren't very scary. They're pretty easy to deal with. You can answer those questions. But for now, I just want to be nice and simple. How do you rewrite that as an exponential? 2 to the 5th power makes 32, which is a true statement. Okay, that's true. These aren't true-false questions. I'm just saying you can check your answer. I didn't put any false statements in here to like confuse you. They're all true. Or they just involve variables. How about B? Log base 6 of 1/36 is equal to -2. Again, that's a true statement. It's a true fact. That's just another way of writing the fact that 6 to the -2 is equal to 1/36. See?
What's E?
What is it?
E.
Oh, problem E?
Yeah.
Oh, we'll get there. Don't worry. I'm glad you're thinking ahead. You're probably maybe a little ahead of some of us. It's okay. It's log natural though, Cheyenne. It's natural log, so it's base E. We'll get there. If I say log of x equals 5, is that a typo? Did they forget to put the number there?
No.
Not really. We live in a base 10 society, so if there's no number there, you can assume it's a 10. Okay?
Oh,
right.
no number,
Okay, yeah.
no number.
Right. We use a base 10 number system, so they get that for some reason gets a special preference. If you look at your calculator, there's like a log button. That's going to take log base 10 of things. Quick example. If I ask my calculator, well, first, okay, let's rewrite. This would say that 10 to the 5th power equals x. What do you think my calculator would tell me if I typed in log of 1,000? Who's got a good guess? Log of 1,000 what would come out of the calculator?
3.
3. Because 10 to the 3rd makes 1,000.
Yeah.
Yes? Cool beans? Okay. D. Y equals log base n of x. This is just like a general formula. That's equivalent to saying n to the y is x. Okay? All right. This is another one. There's another special number out there that comes up like E. So this is the same as saying log base E. Okay. Who remembers what roughly? I have two trivia facts. Well, the first one's not trivial, really. Very close. Very close. It's roughly 2.7.
Yeah, sorry.
Yeah, you're really close. That's good. The important thing is you remember. The important thing is that you know it's just a number that's between 2 and 3. That's really all you got to know about it. Because anytime you're doing a calculation involving E, the computer will have it stored inside its permanent memory. So the important thing really just to is not to be scared of it, not to think it's this mystical, crazy thing. It's just a number, just like pi. So this is like saying, if I rearrange it, it's e to the y power equals x is equivalent to this. Are we okay with that? And then the last one is log base 2. If any of you guys go and study computer science, they use a slightly different notation. Log base 2 gets a special, kind of like ln, because in computer science, log base 2 is so common. But outside of computer science, log base 2 doesn't get such special treatment. So f would just be 2 to the y power equals x minus 1. So you guys feel okay about it? Not scary? All right, how about 4? 4 is not hopefully scary either. You're going to rewrite all of these as logs. So what would A look like? Log base. There you go. Easy peasy, right? That's all there is to it. Right? And so the rest are just some more practice that I hope is sufficient amount of practice for you. If you feel like it's not, like you feel like you need more practice to understand it, I could work with you individually, I guess. 5 is just true or false. Like, are these true? Like, I'll do one example from each. I think they're very straightforward, but we'll do 2 just to make sure there's no confusion. But.
6, 8, 7.
True or false? Log base 2 of 25 would be 5. True or false?
True.
False.
False. Because here's how you can determine. You go rearrange it. Is 2 to the 5th power equal to 25? Is that true? No, that is a false statement. You okay with that? Whereas B, log base 5 of 25 is 2. Is that true or false? That one's true because 5 to the 2 power is 25. Yeah?
Yeah.
And then for 6, don't use a calculator for 6. None of these need a calculator. They're all very, very basic calculations. So when you say evaluate, what you're asking is log base 2 of 128 is what? So we're answering this question. So rephrase the question. This is saying 2 to what power would give us 128? We can count this one on our fingers. Let's do powers of 2. 2 to the 1 is 2. 2 to the 2 is 4. 8. 16, 32,
64, 128.
So the answer was
7.
7. Okay? Some of them might not be, like for example, 5H you might look at that and go, oh, there's a big scary decimal. But think about how that 0.0001 is really just one what?
Over.
Is it 1,000? It's a 10,000. It's a 1/10,000. Right? Okay. Hope that makes sense, guys.